Hi everyone, I'm Cheryl. In this problem, we're asked to find the curvature of a plane curve y equals 5x squared plus 7 at the point x equals -1. And then we're asked to find the radius of curvature. Okay, so let's take a look at my curve, y equals 5x squared plus 7. Notice it's not written as a vector valued function, but that's okay. I can still find the curvature by using this given formula. So I need to find the absolute value of the second derivative of y divided by 1 plus the derivative of y squared, all raised to the 3/2 power. Okay, so I need some information before I'm ready to tackle that formula. So let's go ahead and find out what y prime is, which is simply the derivative. So that's 10x. And the second derivative is 10. Okay, so now I'm ready for my curvature formula. I'm going to take the absolute value of the second derivative. So that's the absolute value of 10. And then I'm going to divide that by 1 plus y prime, which is 10x squared, and then raise all of that to the 3/2 power. Okay? So the absolute value of 10 is just 10, and I have 1 plus 100x squared to the 3/2 power. Now that will give me the curvature at any point, but in particular in this problem, I'm interested in what happens at x equals -1. So when x equals -1, my curvature is going to be 10 divided by 1 plus 100 times -1 squared to the 3/2 power, which is going to be 10 all over, this is going to be 101 to the 3/2 power. That's the exact answer. Excuse me. If you would like an approximation, you can always pull out your calculator and find 10 divided by 101 raised to the 3/2 power. And we get approximately 0.00985. I'll round it off to 5 decimal places. Okay, that's the curvature. The next part of this problem, we're asked to find the radius of curvature. Now, what exactly is a radius of curvature? Well, I have a picture of my graph, 5x squared plus 7x, on the board here. And what I want you to think about is taking a circle and placing it so that the circle passes through the point -112, which is the point we're interested in. And I want to situate this circle so that the tangent at -112 is the same as the tangent of that particular circle. So I'm only going to draw a part of the circle in, but if you can imagine, there's going to be a circle that comes through, and that's part of the arc of the circle. And the tangent to my orange curve is exactly the same thing as the tangent to my circle at the point -112. Right? The radius of curvature is the radius of that circle. And the way we calculate that radius is it turns out that it's simply 1 divided by my curvature. So in this particular problem, I'm going to have 1 divided by 10 all over 101 to the 3/2 power, which can be reduced to 101 to the 3/2 power divided by 10. If we want to get a decimal approximation for this radius of curvature at x equals -1, we can use our calculator and say 101 raised to the 3/2 power divided by 10, and I get approximately 101.50374. I hope that was helpful. Thanks.